in society, again, starting out with so much vocabulary, the front page of this study guide is really just words and definitions. Hey guys. Thank you. So starting out, I broke this down into two categories because what we really have is the difference between two things that are like pretty similar. So the difference between population versus sample, qualitative data versus quantitative data, and then discrete data versus continuous. And so these things obviously go hand in hand, but knowing which one is which and when to use which one, super important. So population versus sample. The population is the entire group being studied. I like to think of it as like in a perfect world, if I could ask everyone that I care about for this question or this survey, who would I be trying to ask? So it's the entire group you want to study, whereas the sample is important because you usually can't ask everyone that you would like to talk to. Either it takes too much time, too much money, it's just kind of hard to do. And usually we can look at a good sample and just use that to summarize what we would probably get from the larger population, as long as we're choosing a good sample. So, for example, if we had an election coming up, for example, like a provincial election, they often like to look at projections for who is going to win the election. And so with that, we're thinking population and sample. If we had an election for the province coming up, what would be a good population to think about? Who do we care about in terms of an election? Whose responses would we be looking for? Everyone in the province. Not quite. Because, for example, you guys, you're in the province. Can you guys vote? No, you're not old enough to vote yet. Every adult in the province. Does that still include everyone that we really need to talk to? Can every single adult vote?
Isn't it like
19 plus, okay. Or I think it's 18 plus, oh gosh. 18, thank you. 19 is for everything else. Even still, everyone 18 and above still counts for more people than what who can actually vote. Because what you need to be is a Canadian resident. You need to be an eligible voter. There's things that can get you like kicked out of being eligible to vote. So really what we're looking at is just all eligible voters in British Columbia. That would be our population. So ideally, if you were trying to figure out what the election was going to turn out as, you would try to ask every single eligible voter in BC. But that's, first of all, impossible. Probably. A lot of time, a lot of money. What we would do instead is consider a sample, where we would just look at some people in the province to get an idea of where they are thinking of voting and seeing how that could lead to some projections. So a sample will always be smaller than the actual population. We'll talk about down here some sampling methods where we've got like good samples versus not so good samples. So here what we could think about for this is just like a subset of the population of the eligible voters in BC, but just maybe like a certain number of them. And specifically, hey guys, please, thank you. We would want to make sure that the subset is pretty representative of the whole province. If we just looked at a number of people in Victoria, that wouldn't necessarily be representative of what the entire province will vote for the election. It would just be talking about Victoria, which we might have different political views than other places. So for this, I'm going to choose just a random number. Let's say 1,500 eligible voters. Although I'm realizing now that I spelled eligible wrong. There's only one L, I think. Well, two, but like one of them at the start. From throughout BC. And so it's a smaller number. Here I just chose 1,500 as like a random subset. Usually the way that I phrase these questions for on a test or something would be a little bit more of a sentence that kind of explains the population in the sample, but you have to tell me which one's which. Okay, next up, we've got the difference between qualitative and quantitative data. So qualitative is descriptive, quantitative is numbers. So next to descriptive, let's write words because it's kind of the difference here. Words versus numbers. So what would be some examples of things that we might measure qualitatively, which is with words? What are some examples? Opinions on stuff, yeah. Thinking about like, what is your favorite sport? Your answer to that would be a word of some sort. It wouldn't be a number. Or we could say like, what is your favorite color or something. So a lot of times the way that I phrase it is like favorite things. Favorite color, favorite sport. It could be like, what kind of pet do you have? But all of these, the answer would be in words, which means that it's qualitative. Quantitative would be things that your answer would be numbers. So that would be things like your age, your height, how many apples you eat in a week. I don't know. Like anything that would be numbers. I'm just going to go with that. You know what I mean. Okay, our next one breaks down all of our quantitative data into either discrete or continuous. And so discrete, like we saw in one of the previous units, this is data that consists of separate countable values. What we saw before is we often said, like, would it make sense to cut this number in half? And that is kind of what we're still thinking. Although even more than just cutting it in half, we're thinking, would it make sense to just keep chopping down this number into smaller and smaller bits? Whereas continuous is when it does make sense to be able to do that. Where if you broke it down, those are still values that like exist. So discrete data, my favorite example for this is the difference between having shoe sizes versus the actual length of your foot. So a shoe size could still be decimal values, only really though for half sizes. Like if you go to buy a pair of shoes, you're probably like an 8 or an 8.5 or something, but you're not going to be like an 8.125. That doesn't exist. You might be technically based on the length of your foot, but you're not getting shoes in that size. Whereas for continuous data, that would be the very similar idea, but we're thinking the actual length of foot. So it's a continuous measurement to just take a ruler up to the size of your foot. But if you're trying to fit that into a specific shoe size, that would be discrete. Okay. Next up down here, what we have are sampling methods. There's not really space for us to fill anything in, so just bear with me and we're just going to read along. What we have are the different ways that we could collect data. Our first way that we talked about was random. Just straight up, everyone in the population has a chance of being selected. So for example, the school puts the names of all 1,200 students into a computer and randomly selects 100 of them to have a survey about the food. Stratified random. Still random, but a more systematic way of approaching it. So what this does is it breaks it down into groups that kind of represent the population in a nice way, and then divides, or takes those groups and picks randomly from each of those. So for example, the school divides students into grades, then randomly selects 25 students from each grade to do a survey about school spirit. Okay. Next up, a less good way of doing a sample is a convenience sample. It's nice because it's obviously convenient. What this is individuals are chosen based on ease of access. Who can you easily ask a question to and will they respond? So for example, a student stands outside the front entrance before school and surveys the first 50 students who walk by. Why is a convenience sample not great? Yeah. You're just specifically getting one subset of the population. If it's this example here, you're just getting the first 50 people that come to school. So you're getting the early risers. That might be a certain demographic of student. You're missing anyone who showed up late. You're missing anyone who showed up like on time. You're just getting those first people that showed up. So it definitely skews the number of people, not the number of people, but the type of people that you're talking to. Our last one is voluntary response. So this is that participants choose to take part. Technically, everyone has a choice, but more so of like a survey link is posted on Google Classroom, asking to share opinions about homework. So students choose whether or not to complete it. It means that you're really only getting the responses from people who want to complete it, who care about having that voice heard, either feeling passionately for or against something, or not, but it's just you're only getting the people who choose to do it. So it really does skew the data a little bit. In terms of skewing data, that's what we call bias. So bias is a factor that causes data or results to be unfair or unrepresentative of the population. And so we talked about 3 specific types of bias. We need to know the differences between these and be able to identify them. So selection bias occurs when some members of the population are more likely to be chosen than others. So our example of the notes was where we had a survey about healthy eating being given to people at a gym. So the people at the gym are more likely to probably care about healthy eating, so it's skewing those results to really just only focus on that, which is fine if that's what you're looking for, but if you were just looking for like general eating habits across Canada, that would skew the results quite a bit. Measurement bias is, it occurs when data is collected using inaccurate tools, inconsistent methods, or if the question influences how the responses might be sent in. So this is where basically it's a not good survey. Basically the questions are wrong, they're leading or they're misleading in certain ways. And so just the way that you're actually measuring this data is off. Our last example of bias is response bias. And so this is where the participants don't want to answer questions honestly. There's ways that you could write a question to maybe make people feel like they should answer it in a different way. So there's some definite overlap there. But this would be, for example, if I said like, how many hours did you study for this test? And you might answer just based on certain ways to either just be perceived in a different way. So you might say that you studied a lot, even if you didn't. You might say that you didn't study at all, even if you did. Whatever way, if the response is what's the bias, then response bias. Makes sense, I guess. But like I said, the first half of the study guide is really just a bunch of words. The thing about this is you need to know these words. So if it gets to the test tomorrow and you're like, wait, what is quantitative? I don't know. You got to tell me that. So puts it all in one place to have all of these definitions on just one sheet of paper. Otherwise, when we flip it over, what we see are different types of graphs. On this study guide, we don't have enough space or time or need to go through each type of one and actually graph it. But we're going to break down just what are the names, and we'll briefly talk about like when we would use each one. What do we call this guy? It's a bar graph. Good old classic bar graph. Technically, it's a vertical bar graph because the bars are going up and down, which is how we're going to leave it for this class. This means that we've got our independent and our dependent, which is quite nice. Consistent with how we've done it in the past. We use bar graphs when we have like categorical data that's separate categories. So like favorite color or favorite sports team or type of animal that you own or anything like that. These are different categories. Next up, it looks like a bar graph, but all of the bars are smushed together. What do we call this one? It's a histogram. And again, these are words that you need to know. So you need to know histogram is going to be squishing them all together. When would we use a histogram instead of a bar graph? Yeah, when the categories kind of blend together. So we've seen this before in our notes. It was the example of like the ages of the people who went to the concerts. And so we had one category was people from 0 to 9 years old. The next category was like 10 to 19 years old. So when we have kind of ranges for these categories and they really blend one into the other, this is when we would blend those bars next to each other. Next up, what do we call this one? It's a line graph. We've seen line graphs quite a bit in Unit 6, I think it was. This is where we have two variables that we're comparing against each other, but specifically the data is following like a trend of some sort where one piece is connected to the next. And so we connect it with a line, really looking at either continuous variables or at least just things that are following the same trend. Whereas the next one, a scatter plot, we specifically will never connect the dots. Because each dot really represents a specific data point that is maybe related to, but not connected to the dots around it. So what we saw in our notes was an example where we had, I think it was our height along the bottom and our shoe size up here. I'm big into shoe sizes on this unit. I don't know why. But each dot represented a different person. And so connecting the dots between people didn't really make as much sense. So these ones, yeah, we leave them away. We'll talk about it in a second. What would this little dot be? Right here. This would be an outlier. Yeah, we talked about that yesterday as part of mean, median, and mode, but a dot that doesn't really fit the rest of the trend is called an outlier. What do we call this one? A pie chart or a circle graph. or circle chart or pie graph. I don't know. Circle graph, we'll call it. Specifically, we want to use circle graphs when we're talking about percentages. So we don't really use a circle graph just to talk about the number of things, because we want this entire circle to add up to 100%. And so if I just had like 12 people like red and 5 people like yellow, it doesn't necessarily add up in a way that makes sense to talk about percentages. So we always convert to percentages for a circle graph. For that reason, we're going to do a whole section on circle graphs because it is a little bit more work and it's a bit of a more new skill compared to just like different kind of graphs that we've seen before. So what we have here is some pretty lame information, but we've got favorite color, red, yellow, green, and blue, number of students who like those colors, and we need to do the work to convert it to a percent. So to calculate a percent, divide the number of things in the category by the total, and then multiply by 100. Or you'll get used to just seeing the decimal number and knowing what that would be as a percent. But because of this, we need to figure out what is the total. Yeah, we see all of the data from the people who I asked about their favorite color. And so we've got 4 plus 3 plus 6 plus 7 means we have a total of 20 people. Which means to calculate each percent, what we would need to do is divide the number of students that like that color by 20. So we would do 4 divided by 20. Your calculator will spit out an answer. What do we get for this one? Yeah, our calculator will straight up say just 0.20. And this is where the multiplying by 100 comes in to really know that it will look like a more normal percent number. So this will give us, 20%. And so that's the number of people that like red. So I should switch that to red. Number of people that like yellow is only 3 out of the 20 people. So we would do 3 divided by 20. What would that give us as our decimal number? 0.15, which would be 15%. You don't have to show your work for this, but I'm just kind of doing it for our notes here. For green, 6 out of the 20 people. So if we divide that, what do we get as our decimal? 0.3, which is 30%. And then blue seems to be our winner. We'll get 0.35, which is 35%. My recommendation when you're graphing the circle graph, I don't really care what order you put it in. They just have to be the proper sizes. So I would specifically recommend starting with any of the ones that just have like a multiple of 10 as their percentage, which I will usually give you at least some of those to get us going. You'll do more of this in other grades. But if we're doing red, which is 20%, the graph is already broken into chunks of 10% pieces of pie, so we need 2 pieces of pie. So this would be red as the favorite color, which is 20%. Next up, I would go 30% next, just because it's also a multiple of 10. And I do want you for every category on the circle graph to put what it represents and the percentage with it. Then we need to get into the ones that are 15 and 35. And so again, I'm picking still nice numbers because if each one is 10%, then 15%, for example, we would have 1 full piece of pie and then half of the next piece of pie. If you can't nicely fit the word inside, draw an arrow like this and write the word outside. Part of what I'm looking for here is nicely graphed things. So if you think that putting the word inside is going to compromise it looking nice, then we want to make different choices. Always good to double check that it should add up to exactly 100%. So here we've got 30 plus another 5, and that's our 35 for blue. Cool. Again, not the most exciting data, but good for practicing graphing. Our last section is what we did yesterday. So this is the measures of center. Again, this is really one of the only ones where we're actually doing math in this unit. So this is the difference between mean, median, mode, range, and outliers. So bunch of words, all of them start with M, mostly. So mean is going to be the average. I like to remember this because the average is the harder one to calculate because you have to add everything up, and if you screw that up, it's kind of annoying, which means it's kind of the mean one. You're a mean one, Mr. Grinch. You got to add all of this stuff up first. So add up all the values and divide by the total number of values. So in our calculator, honestly, the hardest part of this section here is not messing up what you put in your calculator. So try it with me right now. Adding up each of these values. So this is the weight of 8 puppies in a litter. Oh, I know. Man, can you imagine? So adding each of these up very carefully in our calculator. So we're typing in all of these, adding them each time. What do we get as our total here? 45.5. If you got anything other than this, next time you do your mean, take it slow. Add them slowly. If you need to, maybe like underline them as you go, just to like show which ones you've already done so you don't miss anything. Okay, so we get our total is 45.5. What do I do with that? Divide it by the total number of numbers we just added up. So we just added up 8 things. So we're going to divide this by 8. This will tell us the average weight of these puppies. What do we get? We should be getting 5.6 something, I think. And we're going to round that to 5.7. So again, our mean is the mean one because you have to add them all up first. Kind of a lot of work. Okay, our next M word is the median. So this is the middle, and I like to think of it, the median of a highway is that thing, the chunk of concrete going down the middle of the highway to keep you safe from the oncoming traffic. So for this one, we're looking at the middle, but we can't just choose the middle of whatever this list is. We have to put it in order first. Then we find the middle. So this one is also kind of mean because you have to take all of this and place it in order from smallest to largest. This, again, is where I like to cross it out lightly as I go. So our smallest puppy here is 4.0 pounds, or kilograms, sorry. Then we have 2 puppies that are 4.2, twins. Then we have 1 puppy that's 5.4. Then we have 2 5.7s, more twins. Then we have a 6.1. We got our big guy at the end, 10.2. That's my favorite, big chunky guy. Okay, so the median, we need to find the middle. And what happens if we have 8 pieces of data? The middle is technically right here. Which means that what we need to do is find the mean or the average of the 2 things in the middle and find out what's kind of the middle of the middle. Yeah, almost, not quite. So in order to do this, we're going to add those 2 things up and divide by 2 because we're now taking just the average of 2 things. So 5.4 plus 5.7. And because there's 2 things we just brought together to find the average of, we're going to divide by 2. And what do we get in our calculator? 5.55, which means either we keep both decimals or we would round it to 5.6.
Would you take away half a point if we did?
No, this unit I'm pretty nice about rounding. I mostly just give you rounding rules because I don't want to have to walk around and answer the question a million times of like what should I round to. So usually I do actually typically say round to 2 decimal points, in which case we would keep this as 5.55 and we would keep the other one, I forget, what was it? It would be 5.69 for this one if we kept it to 2 decimals. But don't worry about that too much right now. Our next M word is the mode, which is the most. And I like to think that those are similar because they both start with M-O. They both have 4 letters. I don't know. Again, we need to know these words, so I like to come up with dumb ways to remember them. So this is whichever number shows up the most often. It could be more than one thing. It could be none. Or most of the time, it's just one singular thing that shows up most often. What do we have here for the mode? Yeah, we have 2 modes in this case. We have 2 puppies that were 4.2, and we have 2 puppies that were 5.7. So we're going to say both of them. Or I guess all 4 of them, yeah. 2 sets of twin puppies. And next up, no more M's, which is great. We have the range, which is the difference. This is where we're looking at the difference between our biggest puppy and our littlest puppy. Yeah, so what we have here is going from our max and then minus our min. So 10.2 minus 4.0 means our range of the weight of these puppies is 6.2. I don't like that box. Okay, and then the one thing I didn't leave a box here because there wasn't really space for it. But we also have the idea of an outlier. And in later statistics units, you'll learn really how you technically calculate if something's an outlier or just kind of close to being an outlier. For now, we just look at it and say, okay, do we have a number that's way bigger or way smaller than all the others? Yes. And in this case, do we? Yeah. Most certainly. We've got our big puppy here at the maximum range. You'll see the rest of them all fall within 2 pounds or 2.1 pounds of each other. And then this guy is 4.1 pounds bigger than the one that's nearest to its weight. So that's our big guy. This is our outlier. I'm just going to put that down here. Not every set of data will have an outlier. So sometimes it's a completely appropriate response to say none. But in this case, our giant puppy is the one that we're thinking about. We love him. All right.